Uh, Now we're going to shift gears a little bit. We're still in the mode of talking about using quote-unquote real-world behaviors to infer measure skills, but now we're going to talk a little bit about, I'm going to hear a little bit about, I should say, games that were constructed for this purpose. And our first, we're going to have two more presentations today, and then dinner. The two presentations are both from ETS, and they are somewhat linked. The first one is going to give a bit of an overview of this idea, and then the second one is going to go and delve into a more specific example of it that the first one discusses. So our first presenter is Robert Mislevy, and he is the Frederick M. Lord Chair in Measurement and Statistics at ETS, and formerly he was a professor of measurement at the University of Maryland. And I first met Bob actually here at University of Chicago, where he presented a very fascinating presentation on one such game, and we later saw a lot more at ETS. So I hope you guys enjoy it as much as we did. With that, I'll turn it over to Bob.
Okay, going to start off with showing you two assessment tasks. Here's one. You took the GRE more than 10 years ago. You recognize this, or the LSAT. This is a pretty standard kind of assessment task. You see a lot of those. And here's another one. Okay, well, I will start telling you what you would have heard had there been some. This is in a game called SimCity EDU, and early on the name was Pollution Challenge. And this is an assessment that's also a learning platform as well. So there's assessment going on, but it's not like, okay, I've come to measure your intelligence. This is about, okay, you're playing through this game, and in order to win in each of these challenges, you're going to have to figure out some problems in this little SimCity environment here that are involving some aspect of an interactive system. And by looking at what's happening in the city and doing all kinds of actions that you might do, figure out what's happening. And in this particular one, the big problem was in the city, all the Sims are complaining because there's too much pollution. What are we going to do about it? And it's your job to help the mayor figure it out. And the interaction in this particular problem here is that, well, you go and you explore around the city and you find out that there are some old power plants that are pouring out a lot of pollution. And the Sims are unhappy, they're starting to leave. So what you want to do is to get cleaner air in the city. And if you think, okay, well, all I'll do is just bulldoze down these old power plants and put up some new ones, and you go and you bulldoze down all the power plants, there's no power, and all the businesses and factories go out of business, and everybody leaves because there are no more jobs. So what you have to do is to figure out ways that in this system that you're discovering as you're playing, there are interactions between different aspects of the system. So as you're going through, you're figuring out how to do that. And okay, this is the free version. You have to buy one for $10 to get the sound, I guess. Go back to the economics. Yeah. Okay, so that first kind of item that you saw, that fits in pretty much with what people have been doing in assessment for the past 100 years or so. And we've gotten very good at it. And it fits with what you might call the standard educational measurement paradigm. The goal is measuring some construct framed in trait or behavioral psychology, usually getting one overall measure. You have these nice little segmented tasks, which is a lot different than SimCity, where you're interacting with this environment that changes as you act. Each one gives you a well-defined, identifiable response, and you're going to be looking at patterns of those. Usually patterns is how well you can do, how many of those you get right, or how good on the average your essay scores are. And so we've gotten pretty good at that. That's pretty efficient. And it's surprising how far you can get getting measures for, say, who's likely to be successful in Air Force training with this pretty simple idea. And you can see that it fits pretty well with Sam Messig's idea of what assessment design is all about in one very specific case. What do you want to know about people? You can't see that directly. All you can see them do is make things or say things or build things, their performances basically, in some environment, in some situation. So if you're designing, you have to think, okay, what do I really want to know about? Well, then what do I need to see people do in what kinds of situations? So that's how you think about design for the familiar kind of tasks. And what our challenge is now is, well, we have tools now where we can build simulations like that. Ones where you can hear them as well. Ones where you can interact with other people. Ones where you try something out based on how you understand the experiment you're carrying out, and the world tells you, no, that isn't right, and you have to figure out what to do next. So people are going down different paths. So that's really part of our challenge. We have a lot of technology to design environments for people to act in, to capture all kinds of performances that they do. And the big problem is, okay, how do you make sense of that? We're not starting cold, because actually in assessment there is a history of doing this in performance assessment. People have been doing that 50, 60 years, maybe thousands of years, but all at a pretty local and low scale for doing things. And so with the technology, we can do things like one of the projects I work with is with Cisco Networking Academy, where there's simulations of troubleshooting for computer networks, and you can have 100,000 students all around the world doing this at the same time, because you've designed the environment so that they're going through something that looks very much like the real networks and the real affordances that they have, and there are some automatic routines for, even though people are doing different things, capturing what makes sense of that and relating it back to models, say, of troubleshooting. So that's part of our problem. I'll talk a little bit more about that. The other part is psychology. I mentioned that in the standard educational measurement paradigm, trait and behavioral psychology has gotten us a long way. It's not good enough, though, if you're doing things like SimCity, because what you have to worry about in the design and what you have to worry about in the making sense of what people is doing is happening moment by moment. And that really is a good reflection of the nature of what our capabilities are for moving around in the world. You become competent in some domain, say troubleshooting computer networks, not by being able to answer a lot of questions or knowing what the 7 kinds of cables are for connecting, but for interacting with the network. You try something out, it works. You send a ping to this. Does it go through or not? What possible security codes are in there? What would you do to find that out? What would you try to see if this or that is the problem that's going on? Knowing what the situations are, how to recognize them in the world, what you can do about it, how to create situations when you're talking with a person. To do that, measuring traits isn't really good enough. So we're having to think in terms of a much finer grain size of psychology. Cognitive psychology provides a lot of tools for the troubleshooting in Cisco, for troubleshooting. Another project I worked on with the Air Force is troubleshooting hydraulic systems in the F-15. Production rule approximations of what people know and can do is useful there. This is a pretty strong statement that Dick Snow and David Lohman made. They said that, they argued that in assessment, in education more generally, people have been over-interpreting the success that we have had to the degree that we have with this kind of trait in behavioral psychology, especially the trait to thinking about, well, there is such a thing as intelligence. There is such a thing as troubleshooting ability. That when you develop troubleshooting ability, you do it kind of the way that you do in the Network Academy packet tracer simulation environment. You solve problems in that environment. They're completely binding the nature of the problem solving with the systems you're working on. But in conversations with others, in instructional material, you're using words like, well, okay, the fault might be down here or here. Is there some test you can do that will split the search space for you? So you're doing these very specific, grounded things, but you're getting some ideas, some language, some schemas that you can develop as resources that when you go to the next domain and you start thinking about it, you start talking about it, you're still going to have to learn a lot about the F-15 before you can troubleshoot that, but you have some ways to think about it. So what you're doing is you're building up resources. I'm just going to say a little bit about this because it actually connects back with things that Steve was talking about earlier about emergence and about adaptive systems. In the middle here, these are the activities that we do that we understand as humans. We're interacting with each other. We're trying to troubleshoot a computer network. Those are the things that we're doing in real time. And so in this layer here, what you've got literally is billions of people doing hundreds of thousands of individual unique things. How is it that we can ever get along? How is it we can ever buy a toothbrush successfully and the clerk knows what we want? Well, that's because there are regularities, there are patterns in all these things that we're doing at many levels, like in the language that we use, like what it means to go into a store to try to buy something, what it means to troubleshoot F-15s. There are these schemas. They don't have an independent existence other than they are regularities with lots of variation around them in all these individual things that are happening out in the world. If you're going to get good at anything, whether it is interacting with your family when you're a little kid or learning to troubleshoot F-15s, you're going to have to start to become attuned to those patterns. Another thing I'll mention that's come up in our conversations already is that if you live in Japan, or if you live in Alabama, or if you live in New York City, there are different variations of many of those patterns. Some of them you don't see, others you do. That's going to affect what your capabilities are. What your capabilities are is through these individual unique experiences that you have. In situations that are structured around those patterns, you begin to build up an attunement to recognize those situations, to assemble them in a moment, to be able to create them, to be able to act effectively in them. So those are the kinds of things that when we're developing things like simulation and game-based assessment, that's what we have to be aware of. Like in troubleshooting the F-15s, what you need to be able to do is say, okay, everybody is going down different paths as they're doing it. Are they doing actions? Are they doing performances that is consistent, say, with space splitting or serial elimination? How will we know that when we see it? Okay, I'm going to skip down a real lot because I was a real fool to put together 50 slides here. I should have put together like about 7. Here's the challenge. We can capture all this kinds of data and we can engage people in pragmatic aspects of their capability, more and above just static knowledge. And what we need to be able to do is to capture that data and then make sense of it. So when we're doing that, one of my jobs is to say, well, okay, over 100 years in psychometrics, we figured out some tools to make inferences from noisy, sparse data from that standard educational measurement paradigm data. What of that can we capitalize on and use, but also combine with some additional models, with some additional kinds of environments that are interactive for targets that have to do with people's learning of affordances to interact in the real world. The kinds of challenges that we have in psychometrics is that these data look a lot different than the 50 analytical reasoning items like that first one. Continuous activity, not neatly segmented into tasks, conditional dependence among them, which path you're going down. Actions change what the situation is. There may be multiple proficiency involved, and they're brought in different combinations in different situations. Proficiencies may change as you're working through. And in fact, in assessments that are feedback for learning, we really want them to change. We want kids to get better at solving problems and understanding systems in the SimCity one. And some of the simulations, some of the games that we have involve interactions among different examinees or examinees and avatars. So let's see. Got one equation here. This is actually a little more complicated than what you need to model just the straight analytical reasoning items. You're modeling You're modeling some observable outcomes in terms of parameters for people and of the task. Another one that I have added here is effects of the other relevant contextual variables. That becomes really important when you start to have something interactive, conditional dependence, actions of other people. But in the design of very simple assessments, you design them so that those things go away. But here is the link between what you observe and what you want to model it as functions of. And it's a probability distribution because it isn't nailed down. You have propensities. Like in modeling personality and situations, what you can talk about is situations tend to evoke over a population some distributions of kinds of behaviors. People have their own tendencies. When you put the two of those tendencies together, what you get is a distribution for what you think is likely to happen when this person is encountering this situation. So let's see. Here's a picture that I'll use. When you're doing things with even familiar kind of test items, you can do that adaptively, like in adaptive testing. And that is, you can give people items that are harder or easier depending on what they've done. That's a simple application of an idea that we can generalize, and this is one way that we can do it. We can say that these person variables are pervasive across a wide variety of situations. Those situations, when a person is in one, we can hook up what we would observe in that situation and reason backwards to update our belief in a Bayesian fashion about what those proficiencies are. So I'll skip through this and get to an example of how you would do it. Now, in fact, we did do it in things like the SimCity and the high drive hydraulics troubleshooting. Now, here's the thing. You want to make some statements about high-level capabilities of people. What you see is very low-level epiphenomena of what people are doing, details of what they say or do or make. In traditional testing, you get around this really hard problem in one of two ways. With multiple choice, you constrain the situation enough so that people do a fairly simple thing and you know how to interpret it as evidence. You've paid a huge price in constraining the situation. The other way in performance testing historically is you can have very complicated situations down here and you want to capture evidence for higher level competencies, and in the middle here you put a person. You have some expert who knows what they're looking at and interprets it, and some miracle happens in their head. If you're trying to make a simulation or a game and do this automatically on the fly. You can't get away with that. You need some theory about what is important. You need some code for how to identify it, what it means, what it's likely to mean for higher level presentations. So what we do, like in SimCity, we have low level data, points, clicks, mouse moves, things like that. Then we have, see, I'll skip through to the example here. Here's what some of the data looks like in SimCity. And that looks different for every person because everybody is doing different things. You start to move it back from individual unique things at the next level up, a semantic level. There are lots of ways that people might do things, but you can talk about verbs. What are the kinds of things that they're doing? Like bulldozing a power plant or like rezoning and putting up a clean one. Then at that level, you can say, all right, we can identify some tactics here. Like if somebody is bulldozing an inefficient power plant, well, were they doing that before or after they had rezoned and put in a clean burning one or not? If they rezoned and put in a clean one first, that gives you some pretty good evidence, a little less than perfect, but nugget of evidence about their understanding of this situation. Now, some people, as they work through there, might do a lot of these, some might do fewer. There are a lot of other of these, some pre-planned, some discovered from data rules that we have. Yes?
Do you do this scoring ahead of time in principle? Or do you look at the answers and cluster around and just discuss what seems to show up, in which case it seems unique, but Singer to kind of interpret?
Yeah, we usually kind of go back and forth. Because like in SimCity, we had some idea of things that were important, so we'd build those in. Like another project I worked on, it was problem solving in dental hygiene. And one of the things that we asked the hygienist to do was filled out a little artificial insurance form about what they had done, why they did it, and what they saw. And that's pretty authentic to what the real job is. We know it gives us a lot of information, but that's sort of a stepping stone to say, okay, now we can also look at lower level data and find patterns that might be related, correlated with other things that we already have a foothold on. So these things, usually you're going back and forth several times. For that SimCity, we worked with game designers out at EA, the people who do Madden football, and they do lots of play testing all the time. Because when you have environments that are complicated like that, it's pretty hard, very hard compared to multiple choice items to know what people are going to do. So you usually do have to go back and forth, but you use your theory and your task design to give you a starting point so that you're optimizing the environment to begin with to get nuggets of data, and then you fine tune it as you go along.
There is a bigger challenge in terms of how the test taker is going to interpret what they're being asked to do.
Absolutely, absolutely.
You haven't worked it out ahead of time. They can't know.
Absolutely. And so one of the things that I was coming down to, and if I had more than 40 seconds left, but one of the most important bottom lines in this is that standard educational measurement paradigm, that's easier, and it has one of its big advantages. You can kind of drop in out of the sky and give it to anybody, and they kind of already know what the game is. And you know what they're going to do, you know how to interpret the data. This stuff like SimCity or the F-15, those things take a lot of startup time. And maybe more, maybe less, but there are lots of more places where things can go wrong. So we think there's a lot bigger payoff to using this kind of assessment contextualized. We don't think we're going to have this great little game that we can drop in out of the sky and say, what is your troubleshooting theta? Maybe you can do a little better because it's interactive, but the real payoffs come from, okay, here's a person who doesn't know how to troubleshoot F-15s. We can use all this machinery, as well as them working on real F-15s and going to classes, but having lots of practice and lots of feedback in the simulation, in the game, and we know what to do with it. they know what to do, and we can feed back very useful assessment information locally to improve their skills. So that's where I think the big payoff is.
So this is like a teaching tool as much as an assessment tool.
Yeah, and if you're doing things in real time, you don't have that great chasm between what is teaching and what is assessment. You're out in the real world, and simulations are closer to the real world anyway than an SAT is, but they're closer in the importance of you have tight feedback circles between what you do, what it means, and what you would do next. And that's learning on the spot. And that's where the technology really pays off, I think.
Say a sentence about generalizability. I mean, so you do this with SimCity, and you think that that is a good indicator of problem solving in other settings, cases, and so on?
If people are taking bets, I'm probably going to bet against that. But I think it's a very good thing as part of getting somebody to learn to be good at systems thinking, because the way, this is going back to this situative sociocognitive point of view, the way you get better at problem solving, or let's call it systems thinking generally, is you interact hands-on in concrete situations, and especially if somebody is giving you words and ways of thinking about it, maybe representations and diagrams. Then you go to the next thing, and it says, well, yeah, this is an F-15, and it doesn't look like the SimCity environment, but you know what we're doing here, we're doing some space plating here, or you know, here's another negative feedback circle like you saw last week. And you do enough of those things, got to do at least 2, but you do more of those, and that's really the only way that you develop this more generalizable way of doing systems thinking. And so the idea that you can drop in out of the sky and assess somebody's systems thinking, one of the results from standard assessment is low generalizability from complex tasks. How somebody is going to do in the science inquiry solving the paper towel strength problem, and one that is formally very similar, which is sow bugs preferring moisture or light. They're very similar in terms of abstract level skills, but kids do tremendously different. Really well on this one, really bad on that one, depending in large part on previous experiences they've had. You tend to build up these islands of expertise, but then you build up more and you start building bridges between them. And that's really the only way that generalizable skills emerge in people.
But is it the actual performance of the task, the final task you're interested in, or the rate at which people acquire knowledge about how to perform the test? That's another aspect of this, right?
Yes, it is.
Think of it as a measure of intelligence or measure of adaptability or something. I don't know.
Yeah. And Dan Schwartz at Stanford has done a lot of work with this. He calls it a preparation for future learning paradigm. And so, yeah, what you would want to do is have somebody learn a couple things like the SimCity. Then you go to another environment that you know that they're not familiar with and see how quick they pick up the systems thinking in that one. So you can use that as a measure.
And you can also see how it might emerge as a result of
Yeah.
So what's the evidence on that, for example?
Dan's found some pretty impressive evidence. What he has done is worked a lot on sort of discovery versus given some theory first. And what he's found is sort of a match between you fool around in the environment for a while, you learn some things, then after that, you get sort of this debriefing and some overview. Here are some of the words. Then you go back and you try them there. And that gives you your best shot when you go to a next environment for figuring out what's going on. This sort of back and forth best builds up your knowledge structure for future learning. Yeah, in our things, like for the Air Force.
Correlate with IQ. Have you ever looked at that? Somebody who's kind of quick at learning these tasks, you think, might have a very high IQ, or at least maybe a situation-specific IQ. I don't know how that. If you tried a Ravens, for example, the notion would be probably a really smart person could adapt quickly to these new situations, right?
That's what I'd probably bet for. I don't have very much. I don't have any empirical evidence on that, but yeah, Most of my work has been done getting people to learn to do things that they couldn't do before. And like in high drive, getting somebody to pass the course, whether they had to do 12 of those problems or whether they had to do 70 of them, if they eventually got to where they could do it, that was what they cared about. So the structure to help people learn. The rate is interesting because even there, if somebody had been in the course for 3 months and they did 150 problems and they still couldn't do it, they're gone. They're never going to be on the flight line.
Please clarify something for me. Is there a right answer in this game, or are there a number of things that someone can do to get to the same result?
Yeah, there are a variety of things you can do to get to the same result, but to like in this one there, in order to get to a satisfactory solution where you've got lower pollution and still the same or above level, you've got to realize that tearing down old inefficient plants causes jobs to go down and people to move out. And unless you figure out that you're going to have to get new plants up and running first, you're never going to be able to win that game. So there are lots and lots of different ways you can do it, but that's one principle that you have to discover to figure it out. And it's a very deep principle in systems thinking, and that's what the goal of that particular challenge is.
Why SimCity and not the Age of Empires, in which there is it's a game and there is a score and there is someone who wins and someone who loses?
Yeah, well, it's because MacArthur gave us money to do this, and they said you're going to work with EA, and EA says, well, we have SimCity, so you're going to do this in SimCity. Very simple. But another thing that we found too, and it didn't take very long at all to figure this out. If you have a wonderful game like World of Warfare or even the raw SimCity by itself and say, okay, here's a great game and it involves systems thinking, it will be a great assessment if you figure out just how to score it. That usually doesn't work very well because there are way too many things going on. Like in the full SimCity, there are 100 different things that are going on that affect how successful you're going to be. So to strip it down, there's still a lot of things going on in here, but in order to make it so that in order to succeed and to have a very good likelihood of succeeding, it has to be you figuring out this particular feature of the system that's underlying this. That's what we had to boil it down to. In games in general, they are made engaging and interesting by adding on more stuff. A story, additional goals, all of these things can be distracting. So in terms of just raw assessment that you drop in out of the sky, they make for bad assessment then, because there are lots and lots of ways that things can go wrong. If you're just going to drop in out of the sky, like in PISA or the National Assessment, you'd want to have a pretty simple game. You might still have some of the engagement in game, but it can't be too complicated. It can't be something that some people will love and some people will hate. If you want to get into something deeper like this, it makes most sense as part of a course of learning, either self-study or in a class.
Would you think of this in like a longitudinal context? Think about the OECD study. Having them play these games in first grade, second grade, third grade, maybe age adjusting and using that as a replacement for something like an achievement test or something?
Yeah, Katie Salen has some schools. I think one is Chicago and one is in New York, where she does a lot of game playing and game design that the kids are actually doing. And she also, they have to take some tests, but these are the environments where kids are learning things, and so they're tracking performance over time. I don't have details on her results, but yeah, you would want to think about this longitudinally. If you want to think about how to get somebody to do systems thinking, you would never want this SimCity to be the only thing they ever did to that. It might be another game or it might be something else, but it's got to be something where you can start building those bridges between, because that's where systems thinking is, but it only comes out of that, experiencing it in the specifics.
Can I just really ask, so how is this different? I get the sexiness of the games.
Yes.
How is this different from, you know, you're landing on the moon and you only got to bring 10 things and make a rationale why those 10, and there were tasks like this.
Yeah, the big difference is...
And
yeah.
there I could say, come on, list the 10 steps that you would take in the right order.
The big difference is interaction. Like in communication skills, you can get part of the way if you say, here's what the clerk said to you in the store, what would you say next? But if you're carrying on a conversation and everything you and the clerk are saying, especially if the clerk is saying things to push you towards certain pragmatic decisions, that's how you get a higher fidelity measurement, and it's also how you get much higher fidelity in learning. So if you want to use this in feedback and learning, the interaction helps a lot there too. So yeah, and last thing I'll say is that people are doing this thing. There are people who make a lot cooler simulations than we do, but who haven't thought about the psychology or how to do the machine learning and then the psychometrics to make sense of what's coming out. So that's the part that we're working on. That for science and that for MacArthur money.
We have time for one more question.
I wasn't clear on the incentives for the game players.
Yeah, the incentives for the game players, they were doing, the ones that we worked with were in a class. And so they were working, and this was one of the things that they could do. Kids who really liked it could do a lot more of this. Kids who didn't like it did it because they had to in the class, but they had other things that they could do too, which we also think is important. You put a lot of this context, a lot of the challenges in there, and some people love that, and they're more engaged, and they learn better, and other kids hate it. So we don't think of this as a one-shot solution for everybody.
So you didn't incentivize, yeah, you didn't incentivize the outcome.
Oh, you mean in the game?
Yeah.
Oh yeah. They got little badges for doing this. And one other thing I'll say too is that kids could play this multiple times, and sometimes we saw kids come up to a solution and they keep playing and their scores would get a little lower. And so we asked them and think aloud, well, what are you doing? And they say, well, I already know how to get the pollution down and keep the jobs. Now what I'm looking at is the happiness meter. I'm seeing what I can do to keep the Sims most happy as it went along. So they created their own challenge to work from.